End behavior. So we have a picture of Buzz Lightyear because we're going to go to infinity and beyond. End behavior is what happens when we get to a really big number, a really small number. So when x goes to infinity, what's going to happen? When x goes to negative infinity, what happens? Are we going to get really big, or are we going to get really small, or are we going to go to like a certain number, like 5? And that's what our end behavior is. There's a way to write it too. So we're going to like split this in half, and we're going to say as x goes to negative infinity. So as x keeps going this direction, what way is y going? Well, you notice that x goes down, y also goes down. So as x goes to infinity, y goes to negative infinity. That's how we're going to write it here. But that only tells half of the story. We're not getting the whole thing. We have to do this other half as well. So we're going to say as x goes to what? We're going to go to positive infinity this time. What's going to happen to y? Well, y is still going to go down, and it's going to go all the way down to negative infinity. So y goes to negative infinity. That's our end behavior for this equation, for this function. Here, we're going to have some interesting things because our function doesn't go all the way to infinity. It stops. And so it stops at negative 11 and at 11. So what we're going to do is we're going to say that as x goes to one of these stopping points, we're going to explain what happens. So as x goes to negative 11, what happens? Well, it kind of gets close to negative 11. So as x goes to negative 11, our y is going to get close to negative 11. And as x goes to positive 11, so as x goes to positive 11, what happens? Well, our y gets really close to 5. So y goes to 5. And you might be wondering, well, that's an open circle. How do we make sure that we know that like it's not going to do that? By saying that we're going to this or tends to, that means that we're getting closer to it. It doesn't mean that we have to be exactly at that number. It's going to give us an idea of what's going on, not exactly, that doesn't say that this is exactly what's happening. This is a really big thing in calculus, and it is the basis of all the calculus that you will ever do, is your limits and how it happens when you get to a certain number. So with that in mind, go ahead and do a quick check and try and identify the end behavior of each of these graphs. Go ahead and pause and do that. Axis of symmetry, this is the last thing. This is our last hurrah, we can do this. So our axis of symmetry, you have this beautiful butterfly. If you remember back in like elementary school, we cut our butterflies in half. We'd like, or the fun one is you'd get like a piece of paper and you'd fold it in half, and then you'd put like some paint on one side. And so you put a splotch of paint and you'd fold it in half. And then you'd get the same splotch of paint on the other side. And you're like, whoa, that's really cool. And that's the idea of symmetry, is that if something is symmetric, it means that we have the same thing on both sides. Like this little bump right here also exists on the other side of the butterfly, and we could cut the butterfly in half. Or we could put a mirror there on top of the butterfly, and we would see the full picture. The same thing applies with our graphs. So our graphs, our axis of symmetry, is an imaginary line across which the graph is mirrored. So if we were to draw a line and cut it in half, we would notice that every point on one side is mirrored on the other side. And remember that since this is a line, we want to write it as x is equal to something, or that y is equal to something. And just keep that in mind, because some of these, like you're going to see it as x is equal to something. That's your easiest one. But it's a line, it is not just a point, because you have to mirror it across the entire thing. Some things, though, you'll notice aren't going to be symmetric. So this first one here, we notice that it looks like it's almost exactly the same on both sides. In fact, it is. You have a distance of 1 between this line here and our intercept, and you have a distance of 1 between this point here and this intercept. Just like you have a distance between 2 from here to here and here to here. So our axis of symmetry is when x is equal to negative 2. This one here, you could try and cut it here, but that wouldn't work. You could try maybe cut it here, but that still wouldn't work, and do some weird thing. but you're not going to get it so that everything is exactly mirrored. So this one doesn't have an axis of symmetry. It'll only have an axis of symmetry if you can cut it in half and it'll look the same on both sides. So that said, go ahead, identify the axis of symmetry for both of these examples. By the way, both of them have it. After that, this quick check is done and that you're paused, you should be good to go.